our live stream. We're going to see if that works. Seems to, maybe. I don't know. John, is it on?
We might have some lag, so let me refresh.
So, welcome to our Learn to Code Day, second Learn to Code Day in 4 years. That's right. First one was prior to the pandemic, and we had an unfortunate hiatus, but we're back and we're better than ever. Those of you who remember the first one, we were kind of in a small room with a more little dungeon-esque. This is much better, I think, and a definite improvement. So I'm really glad y'all could make it. We're going to have people kind of trickling in as the day goes along. But so how we're going to do this is we're going to start with a couple of presentations. Roberto is going to go over getting KiCad up and running on a couple of platforms, some problems that people might have. Then Ian is going to talk about the tool framework and how you can integrate your code with the overall scheme of how KiCad works with actions and communicates between different parts. And then John is going to talk about
Settings.
Settings, right? Yeah, John's going to talk about settings. Wayne is going to give a presentation on the symbol
schematic
instance data, how the symbols are handled between instances in the different sheets of the schematic. It's a topic that people tend to get into trouble with, and so that will be a good one to kind of integrate. So depending on what you want to work on tools, you want to work on schematics, you want to work on other parts. There'll be a little bit here for everyone. So after we'll do a couple of presentations, take a break. There'll be some coffee out in the lobby here if you need to recharge. And then after we're do some presentations, then we're going to break up into small groups and try and get you started on any of the issues that you brought with you. Any of the features that you want to work on, any of the bugs that particularly piqued your curiosity, and hopefully between you and us, we can get some merge requests pushed out by the end of today. So we have until 5. You're welcome to stay for as long as you like. There's lunch going to be happening at 1 o'clock. And apart from that, any questions before we get started? Okay. All right, Roberto.
Hello. So building KiCad, first step. So who's managed to build KiCad here in the room? Very good. Wayne managed to build. That's a good sign. Okay. For those that didn't manage to build, what platform are you on? Windows. Okay, that'll be the first step.
I managed to set it up for Linux.
Okay, as well. Okay. So first step, you go to the DevDocs website. There's really good instructions there for you to follow. It's good for me to do a bit of a walkthrough. So on Windows, the main compiler we're supporting is Visual Studio, MSVC. So steps to follow. You have to have a few different tools. So you need to have Git, of course, on Windows. Make sure you download Visual Studio with the desktop development with C++ and the CMake tools for Windows. So when you're installing it, make sure you set those 2 options and clone the KiCad repository in a folder in your computer.
Can you comment on the community versus professional that some people seem to be
Yes.
trending toward?
So you can build KiCad with the community version, which is made for being used for open source projects. So it's completely free from Microsoft. So you can just download it and use it. So I'm assuming you already have Visual Studio installed and running. So next is a VC package. So you clone the VC pack, the Microsoft VC package repository, Bootstrap, And then in your KiCad repository that you clone, there is a file called cmake_settings.json.sample. You copy and paste it and rename it to cmake_settings.json. And what you want to do there is at the top of the file, there is a part that says VC package steer. So you need to point that to the directory where you cloned your VC package repository. And next step, you open that KiCad folder, and you're probably going to want to launch view the output window so you can see what's going on. Because as soon as you open the KiCad folder, Visual Studio is going to start setting everything up for you, and it takes a long time. So
How long is that? 2 days or?
it takes us potentially several hours. So here's me last night trying to do that on a clean system. So it just takes time. It didn't finish building by 1 a.m., so it will be some time. At the end of it, when it does finish, you'll get an error, but it's expected. So the error is one of the dependencies isn't there because we can't get it through VC package. So what you're doing there is it's Swig, that dependency. So you download Swig somewhere on your computer in a folder that you're going to keep there. And then you go back to Visual Studio, you look in your project settings, and in the CMake command arguments, you tell it where is the Swig executable located on your computer, and then you should be able to build. So you just build all, and you'll finish generating the CMake, and you should be able to build KiCad. Once you've got KiCad built, hopefully we get to that stage. In order to be able to launch any of the KiCad applications, you need to tell Visual Studio some details about the environment variables that need to be set up in order to correctly run KiCad. So if you go back to the dev docs, there is already there for you a sample that you can use. You can just copy and paste what's shown on the screen. It keeps going down, it's quite a long file. And paste it into your KiCad source, VS folder, also vs.json. And then from then on, you can just start using the debugger and launch KiCad. So that's Windows. Any question there? Just, I think for those.
I have a question.
Yeah.
I didn't even make it so far.
No.
Is that an issue or?
I mean, see if we can.
I think at the
Where
part
did you get
where
stuck?
I couldn't find, I'm not familiar, for instance, with using GitHub for
Okay.
sources and stuff like that. So already there, I was like, okay, I could get in there, I could download the source, I think, but finding it from there.
Okay, so you want Git for
I mean,
Windows?
if it's not a problem going forward,
No, no,
I'll
no.
just move forward and
No
figure it
problem.
out as we go, or I'll join somebody else in.
Don't worry. The first thing you'll need is Git for Windows. So if you don't have that, download it.
Yeah, no,
You have that?
That I got, but
Okay.
it says, you type in the comment and Git, and then you get the source, I guess. But from there, I don't know, if it's downloaded inside Git or if it's.
No, it will be in a folder on your computer. So when you do Git clone, it'll create a folder on your computer with all of the files and in the same folder that you run the command. Okay. So you should be able to see the KiCad repository there when you did Git clone.
Okay.
Do you see it?
There seem to be multiple versions of KiCad in Git. Some copy repositories or something like that.
The other repositories are different tools. There's also for the websites, but the main repository is the one in KiCad code, KiCad.
On GitLab.
And GitLab.
Are you looking at GitLab? When you say there's multiple repositories, are you on the KiCad GitLab one?
Yeah.
Can you? Yeah, I wonder if Roberto, can you open your web browser to GitLab and show how to get there?
The folder structure.
Yes.
Yeah.
I'm seeing myself. Sorry. Why is it?
Because keyword it bookmark for it because it's such a long URL.
No.
If it comes from it. Thank you.
So GitLab.com, KiCad /code/KiCad, and then if you press code and clone with HTTPS, that's the link you want to use. And then you just git clone and that link.
Should be the right one.
Okay. Any other? Yeah.
I saw on the screen some the environment variable run from here to here.
Yes.
What is it? Where is it? Fine.
So you want to create this file launch.vs.json. So you've cloned the KiCad somewhere on your computer, so that'll be this folder. And then inside of that folder, you've got a .vs folder, and inside there you create this file.
So
And
should I know what I should?
yes, so that's
Victor, can you just repeat the question?
Oh.
It'll be helpful. The microphone won't pick up.
Of course.
In the back.
so the question was what was the file? Where is the file located that you need to be able to set all the environment variables in Visual Studio?
Yes, and how should I know which variable?
And how to know what the contents of the
Yes.
file are. So the contents of the file are, if you go back to the dev docs, so that's step one. You go into the dev docs, you go for Windows, Visual Studio, and then, I can't see it here. And you scroll down, running and debugging, and here you've got the contents of the file for you to copy and paste. Okay. Any other questions for building on Windows? Online as well?
Nothing yet.
Nothing yet. Okay. Okay. So on Linux, it's potentially easier, or at least faster. The first thing you do, again, you can go to the dev docs page, and there is a part there that tells you a little bit about where you can get a list of all the dependencies you'll need to build KiCad. And I've got a screenshot here what that looks like. So for Debian Ubuntu Linux, if you click that link, it'll take you to the repository we keep the script for the KiCad package that is built for Linux. And you follow that, and there's two fields that you'll see in there, one that says depends, another one build depends. And those are the packages you'll need for building KiCad. So if I go through Ubuntu first, you also need an extra step. So you should add the KiCad repository, dev repository to your configuration. So there's the command sudo apt repository ppa KiCad /KiCad dev nightly. Can you see that there? Yes. And then going to the link from the dev docs, you'll get to this page. You can't see my mouse. You'll get to this page, and then you find the build depends, and there's a whole list of packages there for you to install, and also depends down here. So then you do sudo apt install and all the packages that you see. Okay, so you do that, install them all. That's for Ubuntu. In Fedora, it's similar. So there'll be there's another link there for you to go to, and then you'll do a DNF install. And again, the list of packages you see, but in this case, it's build requires and requires. So it should make it easy. The commands here are examples. They might not be up to date, so always go to the packaging repository so you can see what the latest dependencies are. And then to build, just clone KiCad, make a folder where you're going to keep your build, run cmake, and then ninja -j number of cores.
Or make if you.
Or make if you prefer make.
I think your commands for make it, you just copy the spec files.
Oh.
They don't have ninja in them.
So make. I think I probably got that.
Yeah. If you did the CMake without the
Yes,
generator,
I
you're going to-
mistake in my slide. Fixed. Okay, any questions for Linux? No?
Why is Linux so simple compared to Windows?
That's Mark. No, I think with Windows it's definitely a lot easier than it used to be, for sure.
It is.
The only negative is on Windows you do have to build all the dependencies yourself.
Yeah, I think it's
Yeah.
the speed more than the ease, and it's because Windows is like Gentoo in that everything is built locally from sources, whereas on starting Linux platforms like Ubuntu, you can get all the dependencies as binaries, which is much faster.
Yeah.
Is there any benefits for using ESL instead if you want to do it on Windows or?
So the question is there any benefit to using WSL Windows Subsystem for Linux? I have built on Windows Subsystem for Linux as well. It's just a lot slower, and anyway, you probably won't be able to then reproduce Windows-specific bugs as well. But once you have all the dependencies built, you don't have to build them again. They'll be cached, and you only need to build KiCad after. Okay? Thank you.
My question, there's a mini GW for building Windows on Linux. Does that work?
It still works, I believe.
Question was.
Oh, sorry. The question was, is the Min GW build system still working on Windows?
Yes.
I believe it still is working. I just don't use it myself.
It's what Jean-Pierre uses.
Okay.
So he keeps it working.
Well, I just been used imagine.
So MSys 2, which I still use when I do Windows because I can just download all the dependencies, is very much a POSIX like Linux. It's just the problem is the debug files become so large that unless you have a really serious computer, the debugging is gonna be really, really slow. That's the only downside to.
Hundreds of gigabytes.
Yeah.
Large.
Yeah, it's the only downside to using MSys 2. But I mean, in terms of just installing the dependencies and running CMake and then make, it works just like Linux in that regard.
And my sister is related to MinGW?
Yes. It's a superset. MinGW is kind of a subset of MSys 2.
Okay. That's it for me. Thank you.
Awesome. Thank you, Roberto.
Good job, everyone.
I mean, I also have DisplayPort if I needed it, but. I need this first. I don't think we have any apples. Okay, the next one we do.
Yeah, while we're waiting for Ian to get set up.
Well, while we're waiting for Linux to decide not to give me a white screen.
Yeah. All
I
right.
think I need to restart.
If anyone needs some extra stickers.
Rats.
Oh, so for you.
I was just looking to see if I remember correctly. I'm not sure that I did. I have to check my pockets.
Does anyone have
Clean your arms.
Yeah, I can always find those. Yeah.
Hey, I've got a verified phone. Oh.
I have to restart Excel.
You can make
Come on, computer. There we go. I'm in retraining. Come on, Linux. Scale teams. Okay. Well, it's because my Linux decided to completely break itself and I had to restart. It gave me a nice large white screen. Well, I have it open again now, so. Luckily with this computer, it starts up fast.
No, so I can try to KiCad PS.
I mean, it's certainly something we can discuss. That's obviously within what we asked you to respect that. Sure. What you're doing. Yeah.
Yeah, starting out with that.
I don't want to start having right out spec document because when you do spec document, it's a public document, nobody comments on it. It will a little bit much at times.
Did this turn off?
That did not happen before.
Here, would you try this? Off
Yeah,
the,
but the problem is, if you unplug it, it's not stuck this way. I don't know why. This was not happening before.
Hey,
Um,
you just. Oh, looks like it just came back.
no, this is a virtual terminal. What's the X? What's X service? How do I restart X service? Do you remember the command to restart
Slash etsy slash init.d slash.
I don't have any.
GM.
I don't have those though.
What if you just go back to the server sometime then?
Well, the problem is, it's there, but the display thinks it's white.
Oh,
Because like when it's changing the frame buffer.
here, let's try,
Try. Well, yeah. I think it needs to be this port.
oh, okay.
AMD is weird with their USB-C. Maybe this will. I have it on Google Drive, so if I just share it, yeah.
Yeah.
Although.
Oh, wait,
No,
looks like,
it's flickering. You can see my mouse is the problem. Let me grab my phone and share it with you. Because, yeah.
wow.
I think I need a new kernel.
You want to just reboot your laptop?
I did that.
With the new plug?
Well, I had it rebooted. I just didn't have it plugged in when it was done that. I can just share.
Here, you can share it to this laptop here.
Visual framework. Share. What's the
Just share it to my username.
KeyPro?
Yeah, sure, KeyPro.
Okay. You should get it now.
Okay. Google Framework. Let's get this.
Like the virtual terminal works, and clearly something. I just need to figure out how to restart X server. Control.
Okay. So, all right, so it's
Yeah.
just, it's gonna
So
show
this
that
is
there.
F5.
I just want to check to
Yep.
make sure we're still streaming. We are. Okay, there you go.
Yep, so just F5 that. Slideshow. Okay. As nice as we said building on Linux was, apparently Linux doesn't like HDMI sometimes. So
Linux.
Okay. The most recent kernels don't like HDMI sometimes. You're on Debian stable.
Debian works nicely. Fedora?
Why is HDMI so much easier in Windows?
This is what I get for being bleeding edge AMD new on this thing. So yeah, I'm waiting for 6.7. So I am going to discuss, probably not so briefly, but we'll see how long it actually takes, a system in KiCad called the tool framework, which if you read the issue tracker, you may have seen us keep mentioning the tool framework as this mysterious thing that sometimes breaks and then crashes everything. But it's basically underpins everything we do. So it's the core system that we have in KiCad for handling user input and then performing actions on the schematic, board, library editors, everything like that. So if you press, for instance, the A key to add a symbol in the schematic editor, that goes through the tool framework. The tool framework handles an action to tell it to add a symbol. That symbol processes, and then it gets added to the schematic. The same thing happens also in the editor frames, like if you do file open, that goes to the tool framework as well. The menu sends an action to the framework, and then it handles that action. And so the way that we do this is the UI library we use is called WX widgets. So if you're doing any dialogues or things like that, it's WX widgets. And that's where the keyboard and menus and toolbars come from. And so the tool framework translates between those events that the operating system and WX widgets gives to this internal KiCad event system in the tool framework. So that puts everything into our system, and we encode information in there that's useful, like mouse position and other kind of things like that. And so the other key point of the tool framework is that it allows context switching between actions and also kind of handling nested actions. So for instance, while you're doing a move command, you can also do a rotate on the object that you're moving. And the tool framework allows that nesting system in there. What it is not doing is it's not doing anything in parallel. It is all single-threaded, single action at a time. It just switches between those actions as it progresses. A quick detour into the ugly about it. It does use hand-coded assembly. So if you think about putting KiCad on a new architecture, this is one of the bottlenecks for that. We do have RISC-V already, so if you want to use RISC-V KiCad, we should build on there, at least from tool framework point of view. I think we had someone even contribute the long arch assembly for the new Chinese processor. But that is one of the key points of bringing up KiCad on a new architecture, is we need the assembly code for the tool framework. And some people get confused by that and wonder why, and it's kind of a legacy thing at this point, but it works. Because the other point is it can be very fragile if you're going into the internals. So my suggestion is do not modify the internals unless you're really experienced or you really want to try and fight with it for a couple months cleaning up the fallout on it. Appropriate XKCD for this is, yes, we keep fixing the bugs that we introduced by trying to fix other bugs. That is the tool framework in a nutshell for the internals. The good news is it works. It does a lot of the time. There are some issues with hotkey processing and some things like non-Latin keyboards where some keys don't work, or shift symbol keys, things like that. But those tend to be minor issues. It does what it's supposed to do. The other thing is it is easy to use for you to add a new feature to KiCad. You can easily go in there, add a new tool, add a new action handler, add a new action, and get something to happen on KiCad without having to touch anything low level. It's all kind of a high level system for you to add new code to KiCad with. So that is one good thing about it from that regard.
But adding new doesn't mean writing assembly.
No, you should never have to touch the assembly unless you're crazy like me. Because that's what I'm doing right now to try and fix GDB. So how do we do user input? This is kind of a flow chart showing where the user input is going. We have three main sources of interaction with a user. We have what we call the AUI toolbars. Those are the toolbars you see on the side, top, and other side of the canvas. We have the menus, both context menu and menu bar menus. And we have keyboard shortcuts, so that all the hotkeys that come in the canvas. So we get those from WX widgets, and some of them are native controls on your computer, some of them are non-native. So for instance, the context menus are what are called native controls on your system, same thing with menu bar menus, which means Apple, Linux, GTK, or Windows actually shows those controls using your system theme, using your system widgets and stuff. The toolbars are non-native though, because we're using a different system called AUI in WX. So WX does all that drawing and processing. But we always get the events from WX to say a user clicked on this menu item, or a user clicked on this toolbar item, or a user pressed these keys on their keyboard. So we get those events from WX, they go into the tool framework, and we translate those events from what WX gives us to a unified format that the rest of the tool framework can handle. Because each of these three events has a different format in WX, they have different content associated with them. We translate them all into an event that we understand generically. We look that up then to find what action that event maps to. And then we dispatch that to a tool. And so what we're going to talk about today is this tool and action handler framework. So everything kind of to the left of the screen is the nitty-gritty internals of the tool framework that as a normal developer you never have to worry about usually. Everything kind of from this side, on the right-hand side under tool, is what you do when you're actually coding a new feature in KiCad. So if we look at I kind of wanted to put up some of the files here if you want to dive into it. We have a folder in source code common called tool, and that's where a lot of these internal ones live. So like we have action toolbar, which is the toolbars that can handle these actions. Action menu, which is the menus that can handle these actions. The key events, action manager and tool dispatcher. And then tool manager actually dispatches the event, unlike the tool dispatcher, which doesn't actually dispatch to the tool. We have a great naming scheme going on. And then the action handler is your code. So this is what is in each frame. We have a lot of different ones of these in the tools, selection tools, edit tools, control tools, pad tool, zone tool. If you name it in KiCad, we have a tool for it sometimes. Yes.
Where does the CLI interface fit into this?
Can you repeat the question?
So the question is where the CLI interface fits in. Right now, the CLI does not actually work with the tool framework itself. Because the tool framework is tied in a lot to this UI library, we don't actually have it separated out enough to be able to have the CLI run an action directly. The CLI actually will essentially call into what this tool is doing on its own. So we have, in an action handler for plotting, for instance, the tool will call into the plotter routine, and the CLI just calls into the plotter routine itself. So right now, we don't have any actions dispatched from the CLI. In the future, we might investigate doing that to try and unify code, but that's...
So extending CLI wouldn't be the best first project.
It might still be worthwhile doing. I think
excellent.
Yeah, CLI is actually, I think, still an easy thing to work with for certain operations that don't require the UI to be present. That's the key with the CLI is some of these tasks have implicit assumptions that a UI is there, like they could pop up an error dialog or they could ask for user information. And so that is done in the action handler. And so one of the other things the CLI does is it doesn't use these action handlers because they have that UI assumption a lot of times. So the CLI removes that assumption from it to make it so you don't have an error pop up in your CI system where you can't see it. So now the rest of the time I'm going to spend kind of discussing what it takes to write a tool or action handler. And so there's three main components that you need if you're doing a new feature or tool /action that you want put into KiCad. The first is an action definition. I'll show you all the examples for this in a little bit. But basically that is the definition of what am I doing on the board, for instance. So it just has the user string, it has the hotkey that's assigned to it, it gives it a name, and sets the menu ID, not menu ID, but the menu name and things like that. So that is a very generic thing that could even be shared by multiple tools, or even multiple programs. So for instance, we have an action for save, an action for save as, an action for place symbol. And those don't know anything about the underlying tool. It's just an action that's generated, that generates an event. The next part is we have a class, a C++ class that contains one tool. So every tool is its own class. And we tend to group like actions in the same tool class. So if you look, we don't do one action per class, but we have various tools, and one tool, for instance, could have, if we look at like board control, you have save as, save, open, all in one tool, but they're different action handlers. And so then inside the tool, we have the action handler methods. So this is a single method inside a tool class, basically, that tool framework will call. So what you can usually do if you're just adding something, a single thing that's new is, usually you can reuse an existing tool class. There's no need to write the entire C++ class for a tool already. You just add a new action handler to an existing tool and add the mapping for it. Now we have two different kinds of handler types. What I'm calling single shot, and then another one that's interactive. I'm not going to be talking about interactive in this because that gets to have a lot more intricacies in it, because you actually have like an event loop running and things like that. So if you want to do anything interactive, it's best to look at examples in the code and ask for help when you're doing that, because there are some gotchas, especially when you're doing interactive. But I will be showing a lot of examples of kind of the single shot method, where a single shot basically means the user clicks the button, it does one thing and just can immediately do that and then return back to the user. So for instance, a single shot would be changing a setting. So the user clicks a menu item, uncheck a menu item, it changes the setting, and then it returns back to the user and the action is done. That's a single shot action. Or rotate is also a single shot action. So, sorry. So definitions. For actions, we define them in the various CPP files that have actions in the name. So we have a common one, actions.cpp, but then every frame, kind of subdirectory in the source code has its own actions as well. So we have PCB actions, EE actions, CVPCB actions, 3D viewer actions, etc. And the thing is, we do mix together like symbol editor and schematic actions, footprint editor and board actions. Those get mixed together, but we do separate GURB view actions from the board viewer, for instance. If something can be used in multiple frames, it goes into common. So that's the actions.cpp in common. So for instance, on the side of the screen here, I have an example common action for save. And so you can see in the definition, action save, and we define the name of it. Scope is global. That's basically what most of the actions are global. We assign a default hotkey of Control plus S, so you can do Control S, and that's the hotkey for it, by default on a computer. So that means if someone has never modified their hotkeys before, they have no existing settings, this is the hotkey that gets assigned to that action. Save has a legacy hotkey name, but this is something you'll never have to work with, because any new action should never have a legacy hotkey name, because that's for mapping from old pre-tool framework to tool framework. And we have to keep that in there so people going from like, V5 or V4 even kind of can build back up to this. So you should never have to modify or add a legacy hotkey name. Then we have things like friendly name, the tooltip, adding icons, those kind of other things in there. Every action must have a name. That's essentially the only thing that's required by the system. Most of the other things are optional because we can have actions that are not meant for any display to the user at all. So name is the only thing that's required. For a full list of kind of what you can set here, there is a class called tool action args. That is how you initialize this action system. This action is with you create a tool action args, passing all the information into it. 1 minute, my phone's going. So the next thing is, sorry, 1 minute. Tool actions can have parameters. And so what a parameter is essentially a way of passing information inside an action to the action handler. So you can think of this, so here are 2 examples of parameters that you can put onto the action. The first one here on the left is adding a settings value, so like an enumeration value into an action. And we can do this essentially so the action for the 3D view rotation, each action gets an enumeration value saying what direction you're rotating, and then we have one action handler that handles all of those actions, and it just pulls the parameter to know exactly what it's supposed to do. So I'll show an example of that in a little bit. So that's one example of parameter. Another one is, for instance, if you want to pass a string or a file name or something like that, we can pass pointers through actions. You just have to specify the exact type of the pointer you're passing. Because in the action system, the type given when you're creating this action and event must match exactly the desired type in the action handler. Otherwise, there will be an assert fired in a debug build saying the types do not match. There's a problem. 1 minute. Sorry. Yeah. Oh. Okay. So action parameters. So some guidelines and tips for using actions. The name is generally of a kind of a 3-part name, where the first part is the program or common. So for instance, we have PCB, I believe it's PCB new dot something, eschema dot something, CVPCB dot something, common dot something. That's kind of, it doesn't really define a scope, but it gives us a visual indication of where the action is used. The next one is kind of the tool category or tool the action is meant for. So for instance, save is a control action. So it's common.control. Place symbol is an interactive drawing action because it's interacting with person drawing. Generate Gerbers is an editor control because it's it's a control action in the editor. And then the last part is the actual kind of name of the action. Save, place symbol, generate Gerbers, rotate counterclockwise, those kinds of names. So this name can be used eventually to also run the action. So the names do have to be unique. I do not believe we actually have a uniqueness check in the code right now. So it's kind of undefined behavior if you do try and run an action by name and it's not unique. Most of the time we do not run actions by name though. We just will create this action and pass it to the tool framework and say, please run this action. So you generally don't run by name. You run by saying action save, not common control save. Because these actions are built at a global static scope. So we have one action save that is inside each DLL essentially that we have, each shared library we have. As I mentioned, not all actions need a default hotkey. And in fact, kind of the policy stance we're doing now is there needs to be a good reason for a default hotkey to be assigned to any new actions. Keyboard space is very limited. And the more default hotkeys we add in there, the fewer keys we have in the future and possibility for collisions to come up and things like that. And a lot of the new tools that might be added generally might be more niche or specialized that if someone really wants to use them a lot of times, they can just go into preferences and add a hotkey themselves for their keyboard mapping. So generally for new tools, we do not add a hotkey to the actions. Icons are also optional for non-toolbar actions. This might need to change in V9 because we might get configurable toolbars if I get to work on that in a couple months. And if we do get configurable toolbars, then any action that can be exposed to the user will need an icon for the toolbar. But as of now, icons are only used in toolbars and menus if the icons are turned on, which is platform dependent, theme dependent, everything like that. So for now, icons are essentially optional for non-toolbar. The other thing is we've started doing where when you initially add a feature, you can add an icon for it, but at the end of every major version kind of development cycle, we will go through and kind of unify the design of all the icons and try and have a consistent UI theme. So any icon added during development is kind of a temporary one until the end, and where we can unify the icon themes. So the icon added at first might not be the final icon, basically.
Yeah, feel free to drop in whatever MS Paint
Yeah.
icon you want there, and we'll clean it up later.
Yeah.
It doesn't need to be anything.
Yeah.
Fancy.
And if you don't want an icon, you just don't put .icon, and it will automatically default to nothing and won't display anything. So if you do not put one of these, it will just get the default, and that will be perfect, and the action will still function. So if you don't put default hotkey, it will just have no hotkey by default. You can still run the action from the menu or toolbar. You can assign a hotkey in the hotkeys pane, and everything can still work.
But adding an action to the menu bars is another story. So this
So adding
installs
so adding the action to the menu bar, I'm going to go over close to the end actually about how you expose this in the UI. This just defines the action in the code. So this lets us have the code say I have an action that is save. It contains all this information that will be used in the UI once it's added there. But also this tells the tool framework this action exists and possibly could have something handling this action.
So whenever you have installed this in the menu somewhere, when it's installed there, it knows which item to use.
So
it's defined there.
So this definition will be used in the UI to make the menu item actually. So what that means is whatever you put here for like the tooltip string is the tooltip for the menu item. And so I am trying to get us to a point where every item in a menu or toolbar is an action. We're not quite there yet. There is some cleanup still to do for items on that. But that is essentially where we're trying to get to the point of having is every item in a menu or toolbar is an action in the code.
Is it the other way around as well? That an action is in the toolbar or is in the toolbar or the menu?
So yeah, the reverse is not always true. The question was basically, does every action have to be in a menu or toolbar? It doesn't have to be. You could have hotkey only actions if you wanted. Generally, if it's something like you're placing an object or opening a dialog, you might put it into the menu bar. Or it might go in the context menu in certain circumstances. Toolbar, adding things to the toolbar is a bit more of a bigger decision to make because we have limited toolbar space right now. I'll actually show you some ways that we've started to work around limited toolbar space when I get to the last part of it. But we definitely do have actions that are internal to the code only. So they have no friendly name, no tooltip, no icon or anything like that. It's literally just an action name and maybe the scope, and that's it.
Can they be nested, like an action that also not an action?
So the question is if they can be nested. So the tool framework supports nested running of actions, but you cannot have like an action save a save as that derives from save. So this definition is not nested, but the tool framework allows you to nest running of actions. Yes, so one action can run another action. And we actually frequently do that where, for instance, you can have the rotate tool will call the select tool and request the selection as an action, for instance, or something like that. So we have kind of that paradigm where one tool will run an action. I don't talk about that in here. If you want to do that, that's something that we can discuss offline or ask, on the developer list, because there are some caveats to how that exactly should work and work. So now moving forward to the tool class. So the tool class is, one tool is one C++ class that inherits from what we call a tool interactive. Or in the frames, it would come from PCB toolbase, EE toolbase, or something else like that in the frame. Inside a tool, there are 4 key methods just to make the tool work. And that's not to make it actually handle any actions, just to make it integrate with the system. There's the constructor, which is you need for C++. You have the initialization, init routine, a reset routine, and set transitions method. Any other methods can be added to it, so you can add the action handlers and helper methods as methods into the tool class. But those are kind of the 4 things that you always need to have in a tool. So the first one, constructor, it's going to usually be empty. And that's because we want to place the default initialization logic inside either init or reset. And you do need to give the tool a name when you're doing the constructor, though. So this is what you pass down into the base class. You give it a name. Again, it has this kind of prefix and tool name, but it's only 2 levels this time, not 3, where the program is the first one and then kind of a name for the tool. So for instance, the inspection tool is what contains the ERC check and things like that, is eschema.inspection tool. That's the tool name. We also have like eschema.draw in place wire or something, something like that, for drawing the wires, drawing the buses, things like that. So that's the tool name as well. That is not used as often, but it's also used in some debug outputs, so you can see what tool is running and things like that. So it is good to kind of be descriptive there. The next method is the init method. So the init method sets up the tool, and actually the main thing that is done in this is you're adding items to context menus. And so the context menu is a bit of a special menu in KiCad, where every frame that has that we have running with a drawing canvas, that we call it, has what's called a selection tool. And that selection tool is what allows you to do the drag selection, click on objects to select them and things like that. But it also controls the context menu that's displayed when the user right clicks. And so to add an item to the context menu, you go and get the selection tool, get the menu, and then you add an item to the menu. Now, this menu is actually what we call a conditional menu. And that's because it will actually hide items that aren't appropriate for the current selection or the current paradigm the user is in. So for instance, if the user has a wire selected on the EE schema canvas, it will hide edit symbol properties. And so it does that by, when you call add item, you give it the action name. So this is adding the exclude marker action. It doesn't say how to handle that action. It just says use the action exclude marker. And then it says I only want it displayed if I have a single non-excluded marker in the selection. So that means I have a single ERC marker selected that has not been excluded before. So that will display the exclude marker. Or for instance, show data sheet. It says I want there to be a single symbol selected and I don't want to be doing any other tool. So for instance, this idle will make it so I don't see show data sheet if I'm moving a single symbol. So you can merge these conditions with and or operators to try and build a kind of a framework for when you want this to be displayed. And so this condition is checked before the context menu is shown every single time. And so actually, if we didn't have these conditions, we would probably have about 200 or so items in a context menu. We put these conditions in there so you only see 20 maybe at most. And they're the ones that you actually need for that part of the code, of the operation. So that's done in the init section. Now, we also have the reset section of the tool. And the reset tool section of the tool is kind of, in certain cases, the tool system will go through and say, reset yourself to a known state. And so this is why I'm saying you should put initialization stuff not in the constructor, but in init and reset, because you do want to make sure the tool can go back to a known state. So for instance, the inspection tool will close any ERC dialogues that are active when it's reset to get back to a known state where there's no dialogues open from the ERC tool. So that's one example of reset. There might be others in the code. You can kind of, grep the code base looking for reset, on a tool and see what they do. Now, the last function that you need is the most important one for making actions actually work. It is what's called set transitions. And what this function does is it defines a transition between an action and a method inside the tool class. So this is what actually tells the tool framework how to handle an action. So to do that, there's the set transitions method, and you just say go with the method name in the class. So in this case, for instance, inspection tool run ERC is the method name of the method inside inspection tools tool class that will handle the run ERC action. Now you have to do the action.make event right now because we kind of have this paradigm where Go maps an event to a handler. That may or may not change if I get time to do that, where we might be able to make it so it can take an action on its own and just make the event for you. But that also allows you to actually say, for instance, we have some events internally that are fired when certain things happen. So for instance, if a new item is selected on the canvas, the tool framework or selection tool will send an event to all the tools saying something has been selected. So events selected event is sent to all the tools. And then you can handle that as well in your tool. So for instance, the schematic editor will call the cross probe method. So when you select an item on the schematic canvas, the selection tool runs, highlights the item for you, you can see it. The inspection tool will get that event here and say, oh, something's been selected. It will call the cross probe method. And the cross probe method, for instance, will dispatch a cross probe to the board editor to say, the schematic editor has selected this item, select this item on the board editor if cross probing is enabled. So that's an internal event that is not exposed to the user. That is only generated by our code. But you can handle that in the same kind of transitions paradigm. And so there could be 10 or 20 of these transitions that you define in a tool, and you can have multiple events mapped to the same method as well. So you can see point selected and selected event both mapped to cross probe. Another example would be if you have the action where you define a parameter of an action for like the setting that you want to set, you can map all of those actions to one method to handle the action. So the 3D viewer does that a lot where, for instance, all those rotation actions just map to one method inside the tool. So you have like 10 of these go lines, one action to rotate, another action to rotate, etc. So now with the tool class, we add action handlers to them. And so what these are is these are a public method that lives inside the tool class. And so it is not static. It is actually going to be a member of the class and operate on a class instance of a tool class. Because when a frame is created, the tool gets created and then kind of lives for the entire frame. So this is going to be running inside a context of a tool that's living in the frame. So you can do things like you can have a frame variable in there. You can have other things that are set there, like for instance, the router mode gets set in the router tool, things like that. The method signature is fairly short. It returns an integer, which is supposed to basically say, did I operate correctly or not? Most of the time, we just actually end up returning 0. And it takes in one argument, which is this tool event. And so a tool event is essentially made from an action. So an event says an action has happened. So that is that action.make event, essentially. This is the result of that make event. And so the event has information about what kind of action was done. It has mouse pointer location for certain actions. It has, I'm trying to think what else it has. It has a parameter if the action has a parameter.
KiCad, welcome, come on.
And so it has a lot of other fields in it as well. You can look in the code base to see what exactly is in the tool event. Not every item is available for every kind of event though. So not every event has a mouse pointer location, for instance. And so if you try and get a mouse pointer event, mouse pointer from a non-mouse event, there will be an assert in the code that triggers saying, whoops, you're trying to get a mouse pointer when there isn't one. So when working with these actions, it is always best to have a debug build of KiCad, because that way you will see these warnings and asserts pop up to say, whoops, something is not how we expect it to run. And that is the main way we communicate something that is not how we expect it in the code. So I kind of talked about this before, but the plumbing of the action handler, every action handler gets a transition line. Again, the argument, address of a member function to the tool event to associate with the handler. So this I touched on before, so I won't go again into it, but it's there. Now, as I mentioned, there's two types of action handlers that you can do. Single shot handlers are usually fairly simple. They just run from start to finish and then they're done with. They don't keep anything, they don't keep any state inside of them. They don't have any sort of letting it yield to let something else run. And so they tend to be fairly simple. So for instance, at the bottom here is a single shot event handler for the 3D viewer to set the material. And so what this does is the tool event has a parameter for the material type, and it just saves that into the renderer, so the 3D viewer setting, and then update the display. And so it just runs through once and it's done. So this is a single shot handler. Other types of this might be, for instance, the rotate tool, where it's just you press R on a component, it selects the component that's under the mouse, rotates it, and it's done. Or rotates the currently selected component. Other ones are what are called interactive handlers. Those ones are more complex. They are going to be things like the move tool, the drawing tool for drawing wires, things like that. They actually contain their own kind of event loop, where they will actually wait for and process these tool events as they come in to do different events based upon if it's a mouse click, a right click, a left click, a drag, a key press, things like that. So those are more complex. I'm not going to talk about them because there's a lot more that goes into them. If you're interested in them, we have a lot of examples in the code. They might not all look the same because they're added by different people at different times. And so if something is uncertain, just go ahead and ask us. We can probably figure it out or say, whoops, that shouldn't be that way. It should actually be some other way. So when in doubt, just ask us about that. So I mentioned the parameters. And so the parameters essentially are used to pass items or information to an action handler. So this is used for things like if you want to handle more than one action inside one action handler for like modifying settings. As I mentioned, the 3D viewer, material selection, you can select a different material type. Each material type has its own action, but there's only one handler for setting the material. And so to access it, you do parameter with the type that you're expecting. So material is an enum type of material mode. Now this type must match exactly to the type that is put into there, otherwise you will get an assert firing. That is actually a new restriction inside the V8 code base because we're now using modern C++. It's no longer a void pointer standard any, for those of you that know the C++ standard library. So that is a new restriction in V8. And so it will give you an assert basically if you do that wrong. So that's why it's important to have those asserts enabled. So now that you have an action defined and you have the action handler skeleton in your tool class, you actually want to be able to do something with it. So I showed an example before where it's updating a setting. So that was the single shot setting update, essentially, where you just go and it can pull it pulls the parameter, sets the setting, and then, for instance, it calls in and refreshes the view. But there are other kinds of actions where you're running on like the drawing canvas of the schematic editor or on the PCB editor. So you're selecting, you'll have items selected that you might want to change. In that case, we want to know what the user has selected or the items that are present on the canvas where the mouse pointer is. And so to do that, we have our tool, our action handler, call into the selection tool that is running. And so you can do that essentially by saying get tool, selection tool, and then in the selection tool, you say, give me the selection, get the selection, and that will either give you the currently selected selection if something is selected, or it will look and say, what is underneath the mouse pointer right now? I'm going to select that and give it back to you. So you can do the get selection, and then with the selection, you can work with it. You have the items essentially that you can work with on the canvas. You can do more complicated things with the selection, where, for instance, get selection will just give you any item that's selected or any item under the point that is selected. But for instance, if you're writing an action handler that should only operate on certain types of items, like for instance, if you're only wanting to operate on line segments and not rectangles or arcs and things like that, you can actually go through and filter out the undesired types and only leave the types you want. This is a bit different, unfortunately, I think, between the schematic and the PCB editor. This is because we transitioned them to the tool framework at different times. But for instance, this is an example code from the PCB editor where essentially you pass in this lambda function into the selection, request selection routine, where you basically, it gives you all the items that are selected, and you can go through and filter out what you don't want and remove anything that you don't want from the selection. So that is a way of saying, I have a tool that, an action that should only operate on certain types. And you can make the selection tool only give you back certain types. Therefore, you don't have to do that manually in your action handler once you do that, once you call the selection. You could if you wanted to, but you don't have to. So for instance, actually this left one, we could have requested the E-schema selection tool to only give us back markers if we really wanted to. Instead, we just get everything back and say, is the first one a marker? Yes?
The selection contains many items, and you want to go back to the user, which one the user wants to pick. So that's something that you have to do there. So you have to pop up like a box and say, which one do you want? Is that done in that function?
So yeah, so the question is, if your selection has multiple items in it and you only want to operate on a certain one, the selection tool will not do that kind of choice, ask the user for that kind of choice. The selection tool will sometimes give you what we call the disambiguation menu, where, for instance, if there are multiple objects underneath your mouse cursor, it will ask you which one do you actually want to select. But it will not say, here is a large selection, which items do you actually want to work with? You will need to do that in your action handler. So that is best done, maybe not in this format where you're doing in the selection tool itself, but once you get the selection, you can go back through and basically, we could maybe give a list to the user and say, which of these items do you actually want to work with, or something like that. The better way, if you know it's based upon type, is going to be just doing this kind of filtering at the beginning, though. Or the paradigm we also go down is we say, if it only can work on one object at a time, we're going to force it to only be active if there's one object in the selection. So we don't have to then go and ask the user, you have 5 objects selected, but we can only operate on one of them. Which one do you want? It's up to the user to select only one item and then run the action. That is generally how we kind of handle that circumstance where if you only want one out of the grouping. So another key part about if you're modifying items is we have in the board and as of V8 in the schematic editor, this thing called a commit structure. And what this commit is this commit is essentially a log of an item and what has changed in the item. And this is important because this is actually what gets used in the undo redo buffer. So if you're modifying an item in your action handler, in order for it to appear in edit undo, it must be in a commit. And so what this allows us to do is this essentially packages up your changes into one system so that we can then remove them or revert them if needed, and also notify the rest of the items that, hey, something has changed. And so it's fairly simple to use. You just create a commit object on the stack. You pass in the frame that the commit goes to. So for instance, this example is a board commit for doing some sort of modification on a shape. I don't remember where exactly I got this from. But you essentially create the commit. You create the shape, or essentially you copy the shape that already exists, the item that already exists. You modify what you want to modify, and then you add it to the commit. You can also delete from the commit, so you can do commit.delete with the item. I think we have some other methods in there as well, other than just add and delete, but those are kind of the two main ones. Then once you're done, you do a commit.push. Just like you do on Git code, we have a commit.push. You push your commit, and this will automatically send it off to the frame and get put in the undo redo buffer and things like that. And then you do give it a string. And this string is what is shown to the user in the undo menu, actually. So for instance, the undo menu will say undo create arc. So then the user also knows what what action they've done, basically. So this is the commit system. As I said, as of V8, so the one that we are working on getting out the door now, this also exists in the schematic editor. I will caution, if you look at the schematic editor, not everything uses this yet, but any new code should use this. So please use the commit system when doing any item modification. And if you're doing something that you think doesn't fit in the commit system, let us know. We can see how it can work, or how we have to change the commit system to make it work. Because not everything might fit nicely right now. We might need to expand it. I definitely know of some cases where we don't, unfortunately, do that. So now we get to the fun part of the user interface. Basically, now that you have an action defined, now that you have a handler for the action defined, how does the user actually run the action that you just made? Because having an action defined is all well and good. Maybe it's programmatic only, but a lot of times you want to add something because you want to display a new dialog box, add a new tool, add a new drawing type, add a new item type, things like that. So now we get into the user interface. Now there's 4 main generators for these actions in the user interface. The first one are the hotkeys. Then we have the menu bar menu. So that's the top menu on the screen that you can click on and drop down. We have the context menu from the right click, and the toolbar buttons on the side, on the toolbars around the canvas. The good news is hotkeys are easy. They just work. You can either give it a default hotkey, or the user assigns a hotkey, and as long as you do the hotkey, it works. The menu bar menu requires you to edit the menu bar creation function. This on every single frame is called do recreate menu bar with kind of a weird capitalization, but that's legacy. It generally exists inside a menu bar something file. So menu bar PCB editor, menu bar SCH frame, whatever it is, it's menu bar something. And this function defines the entire menu bar in one function. So this is a snippet from the PCB editor menu bar creation, where we have a top level menu for the place menu. And so the place menu is like you're giving the user the option of adding new items onto the canvas. So we have a new action menu. Then all you have to do to add an action to the menu is you do add with the action object. And so this is where the menu system will actually go in to the action that you've defined previously and get the user string, the menu item name, and things like that, and automatically create the menu item for you. So all you need to do to put in the menu is add the actions to the menu. And so very easy. You can also have, for instance, if it's a setting, you can have this be, I think it's like an action menu checked or something like that as a second argument in here, where it will display a checkbox on the left side for checked or unchecked. That's another option there if it's a setting that the user can modify. Inside the menu bar menus, you can also create submenus. So this is an example of a submenu for microwave tools. You just create a new action menu for the submenu, set title, we put an icon on it, and just add each action individually again, and then you add it to the main menu again. So that's also fairly simple. So we have a lot of menus up there already. Generally, right now, I think most new actions go in an existing menu. I don't think there's a case we would need a brand new menu yet. We can look at that maybe if there's an exceptional case. But for now, like if you're adding a new item type, you'll have an entry in the place menu. If it's a new inspection item, the inspect menu. Those those menus exist. Now the context menu, as I mentioned before, is a special kind of menu, the conditional menu. It exists inside the frame selection tool. So you have to get the selection, you have to get the menu out of the selection tool. This is done in the init of the tool function. So every tool does the context menu itself. And then, as I mentioned before, you have the Boolean function that computes when this item is shown or not. And so that is going to be added, hiding or showing the menu item in the context menu. So one thing I will say, this last number here is what's called a weight parameter. So this kind of, we can kind of do sorting on the menu and kind of put things based upon the weight into kind of locations. It's not an exact science, but it works. So you can kind of play around with the weight until you get where it should go. Because the problem is because we're adding and removing items from these menus, not every, for instance, not every time you will have a show data sheet in the same kind of, with the exact same items for every single time. So it's kind of a trial and error to get the weight how you want it. So the toolbar interface, we have 4 main toolbars, at least in the PCB editor. I think we also do have 4 in the schematic. I just actually can't remember. The horizontal toolbar above the canvas is the main one that has some actions like save and zoom tools, I think, and things like that in them. We have the vertical toolbar to the right of the canvas. This is V toolbar. The toolbar to the left of the canvas is the optional toolbar. That has mostly settings in it. So, zone fill settings, unit settings, those kinds of things. And then we have what's called an auxiliary toolbar, which is above the canvas, below the other horizontal toolbar. That is where you have the grid selection pop-up box, the PCB editor's track width selection, and things like that. So that's another one where you can add items to it. And so each of those are created inside this function, recreate something toolbar. Every frame has these functions. Some of them might just be empty. So to actually add something to the toolbar, you do an add. So, mdraw toolbar is an action toolbar that's created already in the frame. You do draw toolbar, add with the item the action you want to add. Now, a lot of tools are toggle actions, actually. Those tend to be, if it's an interactive tool, if it's just a setting, for instance, it could also be a toggle to show if the setting is on or off. So, for instance, zone fills will be a toggle setting as well. And so you can specify if it's toggle or not. If it's not toggle, it just means you click it once and there won't be any highlight after you've unclicked it. So you can add to there. Now I mentioned the toolbars are running out of space, especially for small screens. And so what we've introduced quite a while ago actually now. It's already in V7 and it's been working fairly well. Is this idea of an action group which creates a flyout or palette on a toolbar. And so for instance, we use this for the microwave tools, the route tracks tools, the dimensions tools, the grid origin tools, things like that, where if there's like a class of items for placing on the canvas, we can create a pop-up menu that essentially the user can click on, select the item they actually want to place, and place the item. So that is in the code called an action group. You give it a name, so group PCB tune, group PCB routing, and then the actions that are put inside that group. With the first action that you put being the default action shown on the toolbar as soon as the display is opened. Then all you need to do to put it on the toolbar is add group with the group name, and the main selector for it can be a toggle as well. So for instance, the route track tool, because the route track tool should show if the tool is running or not, it's a toggle operation. So we have route tool track, route diff pair, and then you can get to it in the user interface just by hold and drag, or hold and it will automatically fly up and you can go and click on it. And then it will automatically update the icon shown on the toolbar with the current action that was selected. So if you select the diff pair router, it will automatically update the icon to show the diff pair router, and it will toggle it on and off as well. So that's the action group on the toolbar. Now, we also have on the toolbar a lesser known but still somewhat useful, I hope, feature where you can add a toolbar menu to an item. So for instance, if you want to have settings exposed in some cases, like for instance, the router has the different router modes, and originally you would have to open the router settings dialog box, you'd have to click on the item, you'd have to click OK and do that. Now what we have is in V7, we have the ability where you can right click on a toolbar item, it will display this menu that we create in the code and allow you to just modify a setting or open the settings dialog, things like that. So to do that, you create a menu in the toolbar function where it's make route menu. It's actually a lambda that will be called to create the menu when needed. It's an action menu, not a conditional menu, because this is in the toolbar, not in the canvas. So it's an action menu. We don't have any sort of conditional on-off on, not on-off, but show hide on this menu. Everything on this menu will be displayed at all times when it's clicked. And then you just add the actions as normal to a normal menu. So you add router highlight mode. In this case, it's a check mark menu. So you can see that it's checked or unchecked because it's a setting essentially. So you do action menu check. You can add a separator to the menu to separate it out. And then you return the menu. And then to add the context menu is added per action on the toolbar. So even actions in a group, not every action in the group needs to have a context menu. And the context menu will only be displayed when it's in the main toolbar in the group. So then you just do add tool context menu, the action is associated with, and the function, the lambda essentially for, well, in this case, to make the menu. It's a lambda in this case because I need to make the menu twice. And I just want to do it that way. Now, the other fun part. I talked about how the conditional menu allows you to show or hide an action based upon what is in the selection when you open the context menu. That does not work if it's a toolbar button, which is always shown, or the menu bar menus where we do not show or hide items. Everything is always shown. In those cases, we have to enable or disable or check or uncheck the menu item. Now, we have a system for this that we use called conditions. And the action manager sets conditions, and it will check those conditions based on certain Boolean operations that you give it. So this is an example from CVPCB. CVPCB is the old name for assign footprints. It's the dialog inside the schematic editor for assigning the footprints. It has its own tool system, just kind of legacy reasons, but it works. So what we have is there is a function in here that's usually called setup UI conditions or something like that inside the frame already. We usually have some helper definitions up here. And so what you do is you create an action condition, and then you can pass in a function that returns a Boolean. And that function will be what is run on the current selection to say, is the result of this true? Should I show the item or check the item? Or is it false, that I it shouldn't be checked or it shouldn't be enabled? And so you can do that with a .enable or .check. You can actually string those together also. So I could have enable.check. So I could have it disabled in some cases. And then if it's enabled, it's a check item, either checked or unchecked. And so this condition is a Boolean function. You can also do Boolean operations of functions in here. And so essentially it returns true or false. We do have some predefined functions already inside classes called editor conditions. So there's a common one for like content modified, which will say, have the contents of this frame or this canvas been modified? Another common one is, single item selected or no item selected, things like that. So those exist inside editor conditions as kind of pre-made helper conditions that you can use. Then if you want a more esoteric or maybe frame specific condition, you can just create a Lambda function that you pass right into that same update, the same set conditions function. So in this case, in the CVPCB, we want to say, is the filter, is the filter component, filtering component is the filter on this state basically, true or false? And so that will be used inside the conditions to set a check mark on this action. So this will highlight the toolbar button when it's checked, or let it just be a normal button when it's unchecked. Whereas up here, it's enabling or disabling to say, if nothing's been modified, don't let the save button be used. So save is off. But if something has been modified, let the save button be used. Now, one thing about this is this also controls if the hotkeys work. So this will also prevent the hotkey from running, not just the menu and toolbar. That is only the enable condition because checking a hotkey doesn't make any sense. So enable will enable the save hotkey, disable will disable the save hotkey. And so that way you can also make it so they can't run an action when you have more than one item selected if you only want one item. So that is important. This is a condition not just for the UI but also for the hotkeys. So that is the whirlwind tour through the tool framework that we have in KiCad. It is a powerful system, and hopefully I've shown that it can be easy to use. Sorry, if you just want to add simple actions. They can be added very quickly. There's not a lot of code you have to add to it. There's not a lot of boilerplate, and you can easily get something running and being able to actually interact with the user. Now, with that said, it is a complex system and you can do a lot of stuff with it. So when in doubt, look at other actions, look at other action handlers. If you're trying to do something, there's a good chance that kind of system has been done somewhere else in KiCad before, and you can look at the code, see how it's done, something like that. And don't be afraid to ask questions. The tool framework can be a bit daunting. It seems a bit daunting. Sometimes something might not be exposed the way you expect it to be, but ask questions. We can definitely help with trying to point you to the right place or say, oh, that probably isn't the best way of doing it in that one. Look in this handler instead for the way that we want to do it now. This is legacy code that we haven't touched in a while that we need to fix. There are a lot of cases like that actually in the code where tools get written at different times and might do things in different ways. So that is the tool framework. I think I probably did a very long discussion on the tool framework, but hopefully it was useful for people who actually want to implement features now.
May I just take the opportunity to interrupt you guys a little bit? We have having this other room for KiCad there, where it's like theatrical stuff, and you guys are invited to go there and interact and show stuff there too. And I'm hoping we can like have the two community kind of exchanges.
I can envision that the person looks to like good minds and
Yeah.
Excellent. Thanks, George.
And we have also freaking merch and stickers and stuff in the middle room. This small room just here is an extra room that all of us can use. We have no special planning for that room. We're telling people, if you
Extra workspace.
take a few people and do something there, go there. Say those words.
Great.
So that's it.
Thank
All right.
Thank you.
And York organized this whole space.
How was another day? Was it cool?
Yeah, it worked out
It worked really well, yeah. Because I think it was ideal for
Yeah.
what we were doing.
Excellent.
So, are there any questions on the tool framework?
How long has that assembly language stuff been stuck?
The assembly language part of it has been there since the beginning.
Exactly.
And it was copied from the Boost libraries for their context switch. And the problem is we keep thinking we might be able to get rid of it, but then we look at how their API has changed and it doesn't match what we expect anymore.
Exactly.
So therefore we're trying to interact with their library would require rewriting a lot of stuff in our code. I know C++ 20, I believe, has coroutines technically, but they again don't behave like ours behave right now, because the APIs and kind of decisions made changed. So I don't think we're going to be getting rid of it anytime soon. I think it's going to be a fact of KiCad life probably.
I'm the one to blame for this, by the way. It's Tom.
Yeah.
There was also a clandestine, mischievous hidden door to prevent people with PDP 11s stolen from the universities who still hold them in their basements from running KiCad and reporting photos, bug reports. No, seriously, we once had a bug report with someone trying to compile KiCad on some really exotic retro computer architecture, and the switch code became an obstacle.
Yeah.
Yep. So I think now is probably a good time to take a quick 5-minute break, bathroom, get some water, get some coffee. We'll come back here, and next up is John Evans with settings. Great.
Yeah. We just make it one button.
One button.
Yeah. We just make it all one button, get rid of the tool framework. Yeah.
I mean,
I think that would be much better.
you can put one button in all ChatGPT.
Yeah.
I think the problem with mine is it will probably give you back something that fails every single DRC test. But I mean, you can definitely add one button.
That's all we need.
Yeah.
Anyway. I think that was one of my favorite things ever.
Oh, I'm sorry.
You can do the other way around because Windows has the so you can install it. It's not really a terminal.
It was one of
Windows
the virtual framework inside of that TCP.
So Because I would have.
Probably have the impression that there was no separation.
Your home directory.
So at the beginning, there was not, because actually what was happening is, every single,
With the blue framework, that's a little,
Yeah.
so because the tools are written assuming there's a UI to display space.
That's what we like.
So for instance, they will pop up a dialog box asking,
So I keep that one.
Probably
why
the way
open this dialog, open this file, or they might pop up an error message.
Yeah.
Tool handler, action handler saying,
So that is
something happened. So there might be some UI environment still executing the actions. I don't quite know what, John's decision with the upcoming API is gonna be about whether it calls to action handlers.
You can.
Okay. In that case, we might start trying to have to figure out ways of working UI so that we can have headless UI and action handlers and stuff like that probably.
The API is, there's so much stuff added. Because there will be,
Yeah,
Many
actions, maybe the standard
API
API
calls
calls
that
that
will probably only ever work in the UI. Okay.
Eventually, you will be able to start a CLI API server, but that will not be immediate.
so just one switch, not have to stand.
Oh, that one's for actions?
Actions, I don't.
Well, the actions right now.
No, I think it's just one.
It's only a switch, okay.
Well, but the thing is, we
You'll
don't
have
have
like
that
a
action doesn't
setting space.
We have to have some kind of event.
You can actually just run an action with.
This is like a workaround.
Dispatch.
What I have running is.
But that action then calls.
So that's basically.
Yes, that is okay, that is a problem, that would be.
Yes, it's not, the thing is that I have it different, it's a little bit different to the standard. Because we have a manifest mode.
No, you take three,
File, tells Visual Studio what the code is. Download it over to build everything. The thing is, when I navigated the code up and down. Earlier versions of dependencies. So then it was all dependencies. So. It's not good, it's fine if you keep it on the same.
No, that's okay.
Branches not just going forward, but if you want to go back. With all the versions of the.
But that is for.
I'm managing that disabled and I can just do it for you forever. This is really not better today, for example, the manifest.
Okay.
So then I just whatever version they are.
There were storms over the Atlantic, which was, the plane did this quite a lot on the entire flight, and they had to, they diverted it. Normally, you would just go straight over the North Pole and down, and it would be
Even if it takes
a straight flight, but there were storms, so they had to go west and then north, and up, and it was, so the flight was longer than it should have been, but, I mean, from Greece, they probably fly a little lower if you,
Yeah, I'm just about to.
won't go all the way up with but, you know,
It's just really. I think if you just follow, Linux is really easy.
Where's what? Oh, yeah, right. Yeah.
You can see everything that the packager needs.
Yeah.
Some of them are some of the packages are still.
Oh, okay.
But it's just
install it.
installing.
Just install it.
So
I just.
Okay, good, good. I'm glad I forgot.
Put it there, install it.
Send out an email early before everyone signed up, so.
Should I show you? And it has like this one. And then the other.
Well, good. I'm glad you're able to be here. It's really good to,
You can also download binaries on the.
Yeah. With these packages. And it is possible with this package as well, supposedly, to have.
It's good.
The binary saved somewhere.
Okay.
So far, I haven't figured out how to.
I gotta check to make sure the streaming is going. So, all right, yeah, we're still streaming. We're gonna be back in just a couple minutes here. Gonna shut down a few. of these
Okay.
extraneous things so that we don't have as much lag on the audio. Okay, there we go.
Yes, there's coffee. Yeah, but there's sugar. Oh, there's sugar, yes.
Okay.
I brought my tea. It's tea, that is tea, it's tea as well. So I'm not doing KiCad.
Okay.
When that's done, we can, I'm just curious as well to see my computer, because I'm doing the WSL build.
Okay.
And I'm curious to see what it's, with those, I'll put instructions on the forum. But you did manage to get there. The only thing we might need to highlight in the dev docs is this will take all night. Just leave your laptop running.
Yeah, yeah. I think that should be outlined in the instructions that after starting Visual Studio, that will take like forever.
Yeah, leave it running overnight.
Yeah.
I think maybe I'll have that. I forgot two steps in the presentation. One of them I could just actually do a commit, fix it.
Tool action arms or anything like that. And so I think what I should probably do is go through and actually update and make a dev docs page for the tool framework.
Okay, that's a good idea.
Because there are a lot of those things that are so scattered around our code base, like the menu bar, the set UI conditions, that someone won't know that, oh, I can set UI conditions on this. Or that, oh, the toolbar, not toolbar, the menu bar menu is different than the context menu.
Yeah, right.
So, because, I mean, they were the same until I got fed up with it and changed it.
Until Ian came to town.
Well, rebuilding the menus every time they're open was a terrible idea in the menu bar.
Right.
There are update UI events for a reason.
Mm-hmm.
I think Wayne was like, why are we doing this? So,
Yeah. No.
and if it wasn't,
UI events are his hobby horse. So.
if it wasn't for Windows, we could even do it with action menus on the context menu.
Right, but the Windows hotkeys are.
No, not Windows hotkey. Windows has no concept of hiding a menu item.
Oh, really? Mm.
Mac OS, you can say hide menu item.
Mm-hmm.
GTK, you can say hide menu item, and it will actually hide it in the menu itself.
Got it. So it still exists.
So it is in the menu structure.
Yeah, right.
So it's in the menu structure. It's just not straight to the user. And so actually inside the WX widgets code, it does that, I think, when moving preferences from one menu to the Apple. It will hide it in the preferences menu and just add it to the Apple menu.
Clever.
And so I have a branch from like 3 years ago with my WS fork.
Yeah.
Where I was adding that to Apple and GTK and exposing it in the update UI handler. Because update UI events have a show feed. You can say .show false.
Right.
And so many users weren't doing anything that right now. And so I just never fully put that up upstream for redeeming image. Because Windows was always sticking on, but because it's on 2 platforms, so you'll find merging.
Okay.
But it still doesn't let us get rid of it.
No. But now that they're split, it's probably not a big deal.
No, the problem we always had was redrawing the menu bar and re-adding was causing flickering and problems, and so with the action menu, I can sit there.
If I would only agree with that if this will make you comfortable.
I'll look at the,
These tables are better than last time.
Okay.
Yesterday, they did links. Oh, that was super high.
Alex, is the audio still bad?
Yeah, I saw this. The audio was good.
Are you setting this here specifically to keep yourself out of the stream?
No, I'll scoot over. It's to try to help the glare a little bit. We'll see.
Audio still glitching?
Is it still glitching?
I don't know, this was sent 4 minutes ago.
4 minutes, 4 minutes ago, it's still glitching.
Everybody just make your,
No.
it might be the same as Kitty yesterday.
It's streaming directly from, I even ran it in Chrome to try and make sure that it had whatever garbage proprietary Google stuff that they needed for YouTube.
Okay.
All right, I think we're ready to get started again.
If you're online, we are going to start in just a minute. We have some folks still coming back into the room. Okay. Everyone, my name's John. If you are watching online, I realize that the slides are very hard to see. Sorry about that. We will be posting all the slides afterward. So I'm going to talk about how you can understand how settings work in KiCad. So if you need to add some kind of feature where you want it to be configurable, maybe you want something to be a user option that they can turn on and off, or maybe you want to add some kind of data that is stored with a project. This is all handled by the settings framework. I'm going to be a little bit less in-depth than Ian was, so I'm just going to give some overview of things and places to look, and then I can take questions about any specific examples that people would like to know more about. So the big picture for how settings work in KiCad is that everything that is not a design data file, so we have design data meaning boards and schematics and libraries. Everything that is not one of those is stored in JSON format. And these are in various places, like some of them are configuration for your current installation of KiCad, and these are installed in a particular directory that's different on different platforms, but it's for your user on your local machine. So if you have different users, you all have different settings directories. And then the KiCad project files are also these settings files. They have a different file extension, but it's the same format. And so those are the ones that you will see when you actually create your project. And each of these files is represented by a C++ class that is derived from JSON settings. And normally, one class maps up to one file or one type of file, but there's the asterisk here that you can also nest them inside each other. So you can, if it's easier from the coding point of view to break things down into multiple different classes, you can represent an entire class as an entry in a JSON dictionary that is part of a bigger file. And we do that in some places. Within each of these classes, there are these objects called parameters that basically set up a mapping between some kind of C++ data and what's going to be in the file. And then there is this class called settings manager that is responsible for actually owning all of these C++ settings objects and handling saving and loading them from disk and various other things like that. So let's start with an example of you have some new feature you want to add, and you have a basic C++ type. Maybe it's an integer, or maybe it's a Boolean. You just have some flag that you want to store. So there's basically only a couple things that you need to do. You need to determine where to put it, which I will actually cover in more depth later. And then you find where to put it, and then you need to add a C++ variable somewhere. So in this example, you would look in the case of the schematic editor settings, you would go add a variable somewhere inside this class. And if you look at it, you'll see it's kind of organized into different structs that group related settings together. If you have a new setting that seems like it fits in with others, you can add it to one of those existing structs, or you can add a new struct, or you can add a new plain old data variable if you want to. And then in the constructor of this settings class, you will add something like this line at the top. And this is basically creating a parameter that maps a certain JSON path to that variable. And when you read this path, appearance.edit sheet width, what that is referring to is a nested set of dictionary keys in the JSON you can see below. And you can also specify a default value, and there's a few other things that you can do. If you check out the parameters file, you can see there are a number of different parameter types that are built-in supported. You can do things like constrain a parameter. If it's an integer, you can set a minimum and maximum. So if the user or some bug would try to set the integer to some out of range value, it will be clamped when it's loaded, so that your code can assume that it's always going to be within a valid range. And this will result in this kind of JSON showing up. Then you get into types. Well, what if I don't have just a Boolean or an integer, or something that maps directly to something that is supported by JSON? There's a couple different ways of dealing with this. One is if it's a C++ enum type, we can support this directly, so we can map this back and forth from an integer. But say you have some custom object, like for example, color4d is the KiCad color class. Like anywhere we talk about a color, anywhere inside the code base, this is the class we use. One thing you can do is define these functions to JSON from JSON, and these are actually, this is a template that is provided by the JSON library we're using, which is enlum JSON. And if you just provide these in the C++ file and declare it in the header file, then it'll kind of magically work. And the way that these work is you get this JSON object, which you can look up the API for, but basically it's fairly straightforward. It represents an object or a dictionary, and then within that you can add anything you want. So in this really simple example that I picked just because it fits nicely on the screen, we are just using string as the underlying representation because we have these methods already defined with the color class that can convert it back and forth to a string in a certain format. But you don't have to use a string. You can also define an entire big data structure here. Like you can have multiple different key value pairs, you can have lists, whatever makes sense for the thing that you're trying to store. You can set it up using to JSON and from JSON, and it'll just work. There's another option, which is this thing called param lambda. And what this does is it lets you define functions or call functions directly when you are creating the parameter that essentially do that serialization and deserialization back and forth to JSON. This is useful if you are dealing with members of the parameter or members of the settings class that need some kind of complex logic to convert back and forth, and you're not dealing with a data type class. Like color4d is a class that represents a data type, and so it's fairly straightforward to think of, okay, we can add these from JSON and to JSON and use that to convert. But you can also just define arbitrary logic if it doesn't make sense to define those from JSON and to JSON on a particular kind of data. One example here is the net color assignments. Net color assignments is a particular type of map, I believe, if I remember correctly. So you wouldn't necessarily create a custom class just to hold that map and then define to JSON and from JSON for it. Instead, you can do this, where you just write the logic for here's how I want to save this map and here's how I want to load this map. And then that will be called when you need to load that file from disk. And with this Lambda parameter, or this Lambda type of parameter, there's a template parameter that controls how the underlying type is stored. So you saw this one, the Lambda parameter is an element JSON, and that basically means I'm going to pack some kind of arbitrary JSON object, meaning like something that can be inside curly braces, and it could be anything inside there. And I'm going to give it back, and then it's going to just set that net colors key to be that object. But you can also do simple types, like this one is an integer, and it's saying I just want to store a simple integer in the file, but I need some custom function to actually derive that integer. I'm dividing it by 100 or something like that. So you can do things like this where maybe you think that like the internal representation is not the best representation. Maybe you want to change it in the future. And you say, okay, you know what? This actually should just be stored as degrees or whatever. So I'm going to do a conversion here. So once you create a new setting in that settings class, how you access it is pretty straightforward. So the settings manager, like I mentioned, is something that is globally available inside any KiCad application because of how we kind of start up the applications at the beginning. We provide some places for these kind of global singletons that provide different services, including accessing the settings. So in the top example, I'm showing, call this helper to just grab the application settings, and then you can just directly reach in and mess with that data. And then when the application closes, if you have modified that data, it will save it. And you can also trigger a save manually if you want to save it before the user closes the application. And if you do things like open up the preferences window, it will save it when you close and things like that. There are also shortcuts because this is a fairly long line of code at the top. So the major frames like the schematic editor and the PCB editor have helper functions that just reduce the amount of characters you have to type, but it's doing the exact same thing. And these are talking about getting user settings, so the things that are stored per user, and getting things that are stored in the project, like for example, net class settings and things like that. It's pretty similar. It's just a different method to call because you need to load it from whatever project happens to be open instead of sort of the global program state. So there's a few differences there. I don't think I put an example in here, but it's the same few lines of code, just a little bit different. So one thing that this framework supports is migrations. This is basically, if you're familiar with the database world, this is if you need to change your schema and have it handled automatically, we have a facility for this. So if you decide, actually, maybe we shouldn't have stored this setting this way, we want to store it a different way, but we don't want to mess up users who already have the existing version, you can bump the version at the top of the settings file, and then you can register a migration that says, here's how I want to upgrade this setting. So if the user has a file with revision 1, I'm going to reach in and before anything is loaded, I'm going to mess with this JSON data. I'm going to make it actually the new format and do whatever I need to do to upgrade it. So you can use this. You shouldn't use it that often. If you just need to add a new setting, you don't need to migrate it. If you are in a situation where it really doesn't matter, it's not going to be noticed by the user if you throw away an old setting for whatever reason, then don't add a migration. But basically, we want to use this whenever we decide, oh, we really actually need to move this around and we want to preserve the old data. Then you can do something like this. You can also use this, one thing that we do is by default, when you start up a new major version of KiCad, you get this dialog that asks, do you want to import settings from a previous version? And it'll go and look in the common places and offer whatever versions of KiCad it found there. And what that does is basically just copy the files forward. Now, sometimes we realize that something was broken, like a setting was stored by mistake and it shouldn't have been stored, or it was stored in a broken manner. And if we do nothing, then the user won't get the new default. They will just get their old setting, even if that setting was never changed by them and it was just a broken default. So that is one place we've used migrations in a few places, is to, like, when somebody installs KiCad 8, we say, okay, we're going to copy over their settings, but we're going to reach in and we're going to tweak this one bit because we know that the default was wrong and many people have it set wrong. And sometimes that's the right thing to do, even if it means that it will erase someone's settings. We kind of judge that on a case-by-case basis, but it's a facility that's available in case you need it. So if you are thinking, I need to store something, where do you put it? There are a bunch of different classes that exist. You usually won't have to create your new class, a new class just to store your settings, unless you're creating an entirely new part of KiCad. See, these are a few examples. So there's this file called common settings, and this is where things are stored that are in the first tab of preferences and a few other places. This is accessible everywhere in KiCad. So things like language, things that are sort of globals are put in common settings. Then there's another class called app settings base, which holds settings that are used all through KiCad, but you want to have a different copy of it between different applications. This includes things like the user's grid, because a lot of different parts of KiCad have a grid, but you don't want to have the schematic grid setting be the same as the PCB grid setting. So you can define it here, and the setting will be available in both of those applications, but it will be unique between the two applications. And then you have like the particular editor settings, which are a subclass of app settings base. And this is where you add things that only matter to one editor. Then we have two project settings classes. One is project settings and one is project local settings. The main difference is that project local settings is something that you can assume can be thrown away or is not going to move from computer to computer. This would typically be excluded from Git and things like this. And it's basically stuff that allows you to restore your state of work on a particular computer, like what layers are visible and other things like this, where you don't necessarily want to be saving that as part of your design. It's just like, what were you looking at on the design? And then the project settings is where we put everything that is design specific. Now, this is actually like part of your design, but it needs to be shared between the schematic and the board. For example, net classes, text variables, and other things like this that you can access from both editors. So when you go into schematic setup or board setup dialogues, most of what that is touching is stored in the project settings file. And that's basically all I had prepared for slides, a brief introduction of settings. Any questions from that?
Are these settings exposed, or specifically where are these settings that are saved exposed in the UI?
All over the place, but mostly in the project settings, like I said, are in board setup and schematic setup, and all other settings are in the preferences dialog.
Preferences, board setup, I guess, but also some UI state as well, it seems like.
Yeah, so there are a number of things that are stored in settings that are not exposed as like settings widgets that you can tweak. Like, for example, the position of Windows is saved and restored. Unless you're on Wayland, where they decided that that's illegal. other things like, for example, there's separate dialogues for some things, like you can go and configure paths to library environment variables and things like that. That's a separate dialogue, but it's going in the same place. Things like the list of recently opened files is stored there, but it's not something that you can edit in preferences and things like that.
So it really is as much of the state of a working setup that you can save in there.
Yeah.
All right, thank you.
All right.
So up next, we have Wayne with his discussion on similar instances.
Question relates to the statement. Sure, go ahead. The commit log. Is that something that's user accessible?
No, the commit log is not user accessible.
Is that saved somewhere? Can that be passed between instances?
So it is only present when it is running, and we clear it when we close. We've talked about serializing it, but we don't have a facility first. And I don't remember if we have a buffer, so it's like first in hold a certain number. Does that grow infinitely, or?
Well, we do clear it for some things, right? So the commit log does get clear. So if you redo, you clear, if you go undo, and then redo.
Why is it not
undo,
set to
you're
mirror?
gonna clear the redo stack.
You want to undo.
Yeah, right. So you can, the buffer gets periodically cleared when you do certain items. I think when you save.
So you prune the tree. You prune your undo tree.
Yeah.
I think we basically keep it as a list. We don't keep any trees.
Yeah, but it is an infinite list. I think that you can, as long as you're doing items, performing items that can be undone. As long as you're performing items that can be undone, we will keep that list as long as you go. Then every now and again, like you open a new schematic, clear out the list.
Is it bad if you can serialize that to add that to the settings? So save
No.
I don't think we would we never add that to settings because there's no point in keeping it alive, really.
Yeah, you can just rule on a different instance. You
I know that there are some graphical editors that will keep the edit state stored in the file, for instance. I don't think we ever stored in settings. Maybe project local settings.
I'm sure relying on KiCad on being able to undo stuff, so I'm trying something and I'm relying on being able to
Do
stuff.
We were talking about a diff based on commit log. Essentially, every commit is, you're making a change on the board, you can then kind of have a list of all the changes ever made.
Right, yeah,
But
and things like Eclipse, right? If you open up Eclipse, you see the entire file history.
Like, the thing was that I rely on being able to undo stuff while I'm trying something, and not KiCad, but I've had apps in which I do the same thing, that I crash and then I lose that.
Of course, KiCad would never crash.
I'm not talking about Photoshop.
Yeah.
It's an interesting feature idea. We don't currently do it, but there's nothing there's nothing inherently wrong with doing that if the only question is
Serialization.
It's another thing that
we
I
do
say.
it, right, no, can we do it in such a way that it is useful and reliable? Because as soon as it stops being reliable, then it's
So
problematic.
we ready to get started here?
Whenever
All right.
you're ready, Wayne.
All right. So for those of you who don't know who I am, I'm Wayne Stanball. I'm the KiCad project leader, and I'm going to talk a little bit about schematic instance data. And this is a bit of an arcane, difficult to understand part of KiCad, but if you're going to work on the schematic editor in any meaningful way, it's something that you have to kind of wrap your head around. I will say from experience that virtually everybody who's ever touched instance data has gotten it wrong at least once, some of us multiple times. It's difficult to work with, but it's important you understand it if you're going to contribute, because it affects hierarchical sheets and symbols. So that's pretty much the bulk of what a schematic is. So it is kind of fundamentally important that you understand it. So just to go over some rough concepts, most of you are aware of this, but it just kind of helps to have a little refresher. So schematic sheets are the little squares that allow you to break your complex schematic into smaller, more manageable pieces. Yeah, you can make an E-size schematic and put everything on one gigantic page, but that doesn't make for a very readable schematic. So we support hierarchical sheets. The nice thing about sheets is it also provides a simple way to reuse schematics in the same project as well as between projects. I'm going to talk more about that later because we're going to make a restriction on that coming in version 9. There's no real limit on the number of sheets you can use in a design other than how much ever memory your computer has. So we have some customers that have 290 sheet schematics, massive schematics. So it does happen. So hierarchies. So most of us are familiar with the hierarchies. You have a sheet inside a sheet inside a sheet, and so KiCad keeps track of those by linking the paths of those sheets together in the order that you see them on your schematic, right? And those sheet paths have no depth either. So you can make a sheet path as deep as you want. You could have, like I said, until you ran out of memory, you can go as deep with those sheet paths as you want. We don't use sheet names other than for display purposes. Internally, all our sheet paths are actually globally unique identifiers, or UUID, some people call them that. And the reason that is we can guarantee those are unique. Sheet names we cannot, so sheet names aren't reliable. So if you start sharing sheets between projects, you may get a name clash, whereas you'll never get a UUID clash, and that's why we save things with identifiers. So none of this would even be a problem. We wouldn't even have to have this conversation if every KiCad would limit everything to a simple hierarchy, which means there would be a one-to-one relationship between each sheet and its associated schematic file. If we didn't allow any sharing either within the same project or across other projects, this talk wouldn't exist, because there would only be one instance of the data for that sheet, for every sheet inside that sheet and every symbol inside that sheet. There would only be one reference, and we could just store all the data in the file directly as in its default location, and it wouldn't matter. However, complex hierarchies is where we run into complexity, and that's why this talk is important. So we allow sheets to share a single schematic. So in other words, let's say the classic example is you have an 8-channel A to D converter board, and you have a signal conditioning section for each channel, and it's identical. Well, you don't want to redraw that 8 times. You just want to be able to reference it 8 times and the same schematic 8 times. And then when you update that one schematic, all 8 channels get updated at the same time. So that's the beauty of complex hierarchies. But what that does is it makes kind of an infinitely more complex internal structure for KiCad to manage, because now we have to be able, for each sheet that shares that schematic, that creates what we call instance data. In other words, there's another instance of that schematic being used. Even though nothing else in the schematic is changing, all the data is changing. So for each instance of both the symbol and the sheets in that particular schematic. So right now, instance data only applies to symbol references and units, and sheet page numbers. So there's going to be instance data for sheets and symbols. There's no instance data for anything else like wires and buses. That doesn't get instance data. It does affect it, but it doesn't get instance data. You can't change the bus in one instance and then on a different instance. For example, you can only change reference designators, which unit of a multi-unit symbol you want, and the sheet page number. One of the things that we did originally in KiCad is we allowed sharing schematics across projects. This creates its own unique set of issues because now we pollute a schematic file with multiple projects. So when you do that, if you look in your instance data, and I'll give you an example of this later, you might see instance data in there that has nothing to do with the project that you're currently working on. However, you have to understand this so you don't clobber somebody else's data when you're working in the schematic editor. Now, some of this is handled automatically, but you still have to be aware of it so you don't accidentally go in and start messing with instance data that you don't care about, because otherwise you could break the instance for another project. So internally, the way this works is if you look here, the root sheet, KiCad doesn't create a it's kind of a pseudo sheet that we create internally with KiCad. You know, when you have your root schematic, there's no sheet associated with that schematic, but we do create one internally. And because it's virtual, we have no way. So we assign the schematic each schematic file a unique UUID. And here you can see it's highlighted in blue. That's the UUI. All the examples I'm showing here are in the KiCad complex hierarchy demo. So if you want to open the files, like this is the schematic file, complex hierarchy dot KiCad_SCH. You can open it with a plain text editor and you'll see this. So the first line is the header and the very next line is the UUID for that schematic file. And in this case, you'll notice it's 5B9623A. That's the UUID. Okay. So instance information is always accessed by the full sheet path, even if there's no instance data. In other words, you just have the single instance, we still use the paths to access the data. And the reason we do that is for symmetry. So we don't have to have two separate algorithms for annotating, everything's done through the sheet path. And of course, the sheet path is nothing more than all the UUIDs stacked up and literally looks like a file path. So you'll have the root is the first one, sheet one is the next one, and then sheet two will be a subsheet of sheet one, and then all the way out to the very last sheet as far as you drill down until you get to the last sheet in a hierarchy, and that will be your full path. So the sheet paths will get you to the object you're looking for. In other words, the actual object itself, UUID, won't be appended on the end of that. It just gets you down to where in the sheet hierarchy that particular instance data exists. Okay. So one of the things that is interesting about KiCad is sheets are loaded using a recursive descent parser. So what happens is as it's going down through the loading KiCad, as each schematic file is loaded, as it walks up and down the tree, if it finds a file that's already been loaded, it doesn't load it again. It just creates a pointer back to the file that's already loaded. One of the things that you do have to be careful with sharing sheets is you can create a recursion loop. Because we use a recursive descent parser, that you always have to check before you add a new sheet to make sure. So if I have a chain of sheets and I pick one out from the middle and I try to put it in a sheet further up the chain, what will happen is the recursive parser will go here, it'll go up and go, oh, okay, I'm back here. And eventually it'll run out of memory and crash. So we do have tooling in place for allow you to check to make sure you don't create a recursive and it's called check recursion. It's in the some of the objects I'll talk about later. So these are just some of the things that you have to be aware of when you're dealing with schematic hierarchies. So the objects here, I'm going to talk about some of the objects. So every hierarchy path is the SCH sheet path object, right? And that's what contains and stores the sheet paths, right? And there's one for each. When we rebuild the hierarchy, and most of this stuff we do on the fly, we don't keep it around to let it go stale because it's fairly inexpensive to rebuild these on the fly because they're just links, just a link chain of pointers. So it's fairly inexpensive. And what we do is we have another object that maintains the list of those called SCH sheet list. And if you give the SCH sheet list the root screen, you get the full hierarchy for the entire schematic. You can also give it a sub sheet and you can just work on a hierarchy list for a certain section of the schematic as well. So one of the things about GUIDs is they're kind of complex. They're a little messy. So we have some helper classes to help. We wrap. There's the KIID object. It's just a wrapper around boost UUID with some helper functions to make things like converting the strings and for printing and saving the files. There's also a path of those, a KIID path that's just a vector of those KIID objects. And so so those are related to sheet paths. So sheet paths can you can create a KIID for comparison purposes and output purposes from the sheet path object. So here's what instance data looks like. So here's a sheet and I've chopped out all the boilerplate stuff, but here's inside the complex hierarchy, there's a sheet. There's actually two sheets that are shared. And the one sheet has its own internal UUID, which is, you can tell this one's been converted from an old copy of KiCad because it has all zeros in the beginning of the UUID. But you see here, the instance data for that sheet. Okay, so we're looking inside the sheet definition in the KiCad schematic file format. You'll see an instances that every sheet and every symbol will have an instances section. And then inside each section, there will be a project. So we group instance data per project. So if you're using that file like in multiple projects, you'll see multiple project sections in that in the instances section. Path is actually a KID that we generated from the sheet path, the schematic sheet path that I mentioned earlier. And then here, page 2, that's the page number of that particular sheet, right? So that's the instance data for the sheet inside. So if you go back here and look, in my earlier example, you'll see that the UUID is the root sheet UUID. So this is one level down from root. And you look in the path and it's one level down from root. So that sheet exists one level down from the root sheet. And of course, if it was 2 levels, there'd be another UUID. If it was 3 levels, there'd be another UUID. You can see UUIDs get complex, right? So they're hard to look at, but we need to guarantee uniqueness in the paths to ensure that we don't have a clash in the instance data. So the other object that you care about is schematic symbol instances. So all schematic symbols will also have instance data inside them. Right now, only reference designators and the unit are supported by the symbol instance path. There's still some remaining members, M value and M footprint, which we don't use anymore. We just have them in there to be able to load when we were doing that. We'll talk about a little bit of that going forward. So inside, here's what a symbol looks like. So the definition for the instance data inside a symbol. Now notice, so this symbol's been shared twice by two. If you looked in the instances data, you see two paths, two sections of instance data, which is defined by path. And you notice in this case, there's two. And one's for the one sheet and one's for the other sheet that it's shared with. And if you notice, now we have two sheet paths. The first one is root, okay? And then the next one, now I didn't show both paths, but if you go back and look at the previous one, you'll notice that the UUID for the path is 4B3A1333. That's the top instance, right? That's the instance. So that's the instance of that symbol in that sheet. And then you notice it has a reference designator of R26 and unit number 1. So in the other sheet, that reference is R28, unit 1. So when I leave the first one, sheet will be R26. When I go back up and then go into the other sheet, it'll change to R28, but it won't read. The only thing it does is update the reference designator and which unit is displayed. So that's so you can use nothing else in the schematic has changed. We just flip. So when you're using shared sheets, you're just changing the instance data as you move through the sheets when they're shared. And the reason this is important is so each one of those instances will have its own instance data, but it will also affect things like connectivity because they're technically two different sheets, right? So you have twice as many instances, you have however many instances of a given sheet that you share. They all have to have their own unique connectivity information. And that's also handled by the schematic sheet paths. So everything you do in the schematic editor that will affect connectivity, you have to understand this concept. Otherwise, you'll miss, like what mistake a lot of people do is they say, oh, this is a schematic, right? And you do the connectivity check on that schematic. But as soon as you share that schematic, now you have to do that connectivity check for every instance of that because that's the full connectivity, not just the schematic. You have to do it for each instance. Every time you reuse that schematic, it has to calculate a set of connections to that particular instance. So it's important that you understand that. So that's it. That's basically it for the rough concepts. And I know this is a little bit of an arcane subject, but if you're going to, like I said, unless you're just updating dialogue, well, even if you're updating dialogues, because if your dialogue needs instance data, you have to understand this. If you don't, you're going to get in trouble because you're going to end up modifying something that you actually think you're modifying, but you're not. So it's important that you understand instance data. It's one of those things that if you have trouble with and you want to ask the question on the developer's mailing list, it's an important thing that you ask if you're not sure. So anybody have any questions about instance data? Yeah. So a KAID is actually just the object, the class, the C++ class that handles the UUIDs, right? So the UUIDs are, we don't handle them raw. We actually have a wrapper item. Yeah, it's just a wrapper around Boost UUID, but it's in, if you're looking for the file, it's in include.kiid.h.
We start everything with KI in order to disambiguate with other things, and this is an identification number, so it's the key ID.
KiCad's UUID, so KIID. Yeah, that's the naming.
And then wondering why UUIDs are used and not just a hash of the schematic?
You need to be able to generate these very quickly.
That also needs to be constant when you modify the schematic.
Yes, it has to be constant, yeah, because you're referencing data that exists and that's why we have to use unique globally. They have to be globally unique, and they have to be globally unique across projects too, because if you have a UUID clash, you won't be able to, if you,
That would be the case with the hash itself, but you want to not change.
yeah, no.
But if you had, for example, if you had two identical symbols placed, you wouldn't want to just hash them by their value, because you want them both to have different IDs, even if they have identical contents.
Yeah.
Okay, thank you. All right, let's take a 5-minute break.
Is it one
And then we've got one more talk. Tell us about routers. So routers. Okay, maybe we'll do Tom's router talk later this afternoon. We can take a quick break, and then we'll dive into what you guys want to work on. Okay, thank you for joining us, and we're going to end the stream right now and go into local work. So join us next year for more KiCad Learn to Code.